Welcome to IOQM 2021 paper. Let's do the part 4 of the paper. So in this video, we will cover questions from 22 to 26. So just note down these are all 5 marks questions. So let's see how easy or complicated they are. Yeah, the first question is in a triangle ABC, let PR be the feet of the perpendiculars. Okay, from A onto external and internal bisectors of ABC respectively. Let Q and S be the feet of the perpendiculars from A onto the internal and external bisectors of ACB, respectively. If PQ equal PQ, QR, and RS are given, what is the area of triangle ABC? Okay. So if you see the problem, the constructing the triangle is a bit complicated actually. So read the question carefully. So ABC is the triangle. Okay. P and R are the feet of the perpendiculars from A onto internal and external bisectors of ABC respectively. Okay. From A, if you take angle ABC, right? So if you see this one, this is the angular bisector here, BR. So from A, we draw a perpendicular onto BR. BR is the AR is the perpendicular to BR basically. Okay. Similarly, AP AP is perpendicular to angular bisector of external angle B. Okay. So this is angle actually, not triangle. This is angle. Bisectors of angle ABC. This is also angle ACB. Okay. Similarly, from A, there is at C there is the internal angular bisector, and Q is the perpendicular onto that, and this is the external angular bisector, and S is the perpendicular on this. Okay. So now this is the diagram which we have done without these angles. We will prove. Only thing is it possible that all the PQ, RNS are collinear? Okay. Uh, that actually gives us a clue for solving this problem easily. Okay. So first thing is let us prove PR is parallel to BC, PR is parallel to BC, QS is parallel to BC, and QR is parallel to BC. That means basically PB, QR, NS all are collinear basically, right? PM, QR, and S are collinear. Okay. So first let's prove they are parallel. If I take APBR, APBR, okay. Two opposites are 90 degrees here. Okay. Correct. APB and BR are 90 degrees. Then PBR equal to angle A plus angle C by 2. Correct. Plus angle B by 2 means external angle is A plus C, internal angle is B. So this is basically angle PBR is internal angular bisector plus external angular bisector. So that is angle A plus angle C plus angle B by 2. Okay. We know that angles in a triangle are sum of angles in a triangle are 180 degrees. So it will be 90 degrees. So PAR also 90 degrees. PBR also 90 degrees, same way. Okay. So this is a rectangle basically. APBR is a rectangle. Okay. And obviously PR and AB are diagonals. So M is the midpoint. Okay. So note down all these rectangle properties. Remember those. Okay. These are all useful. Next. And also M is the circumcenter of APB. Why? APB is a right angle triangle. M is the midpoint of AB. So obviously this is the circumcenter of APB. Okay. So remember this. Okay. Similarly, same thing we can prove for AQ. Of course, one more property is APBR. APBR is cyclical because opposite angles are 180 degrees. So it is cyclical, right? So now PAB and ABR, these two will be equal to APR, APR, okay. All this will be B by 2, okay. Note down that. So, angle PRB equal to RBC, that is RBC is also B by 2. So that means PR is parallel to BC, correct? Because if this angle here is equal to this angle, that means these two lines are parallel and this is the transversal, correct? Opposite angles, okay? Now similarly, we can prove same thing for AQCS, correct? It will be a rectangle. All will be 90 degrees. N will be the midpoint of AC. N will be the circumcenter. And then QS will be parallel to BC. All this can be proved. Okay. Similarly, we can prove QR is parallel to BC. All these three all can be proved. Which means basically P, B, Q, R, and S is collinear and parallel to BC. Okay. And M and N are the midpoints of AB and AC respectively. Okay. Now we have done half of the work. Now this is a simple. APPR is a rectangle. So AB equal to PR diagonals. Obviously AB equal to PR diagonals. PQ plus QR equal to 7 plus 6, which is equal to PQ plus QR is nothing but PR. So PR equal to PQ plus QR, which is 13. So AB also 13. Correct? Now AQCS is also rectangle. From here we will get AC or QS equal to 14 basically. Okay. Now M and N are midpoints of AB and AC. So BC equal to 2MN. Why? Because this is parallel to BC and these are midpoints. So from triangle theorems, we know that MN will be the half of BC because it is at the midpoint. Okay. So BC equal to 2MN. MN I am rewriting is as MR plus QN, MR plus QN. Okay. So QR is repeated, so I am subtracting one QR. Okay, minus QR. That is equal to MR is nothing but half of AB because MR is half of PR, PR is AB. Okay, so that is AB by 2. Similarly, QN is AC by 2, and QR is nothing but QR is given value anyway. Okay, so if I substitute all the values, I get BC as 15. Okay, fine. Now I got AB, AC, BC. Okay. So three sides of the triangle I got. So now I can apply area of the triangle theorem using this one. Square root of S into S minus A into S minus B into S minus C. S equal to 13 plus 14 plus 15 by 2, which is equal to 21. If I substitute these values, I get area of triangle ABC as 84 square units. Okay. So the complicated thing is drawing the picture and starting with a point that PBQRNS is collinear. Okay, this is the most important observation you should have. So if you play with the geometry more, you will get these ideas. Okay, so this is hard, definitely. Drawing the picture is not so easy, and observing that this is collinear, right? Okay, next. In circle of a scale and triangle ABC touches BC at D. Okay, in circle of a scale and triangle, this is scale and triangle, let's assume. It looks equilateral, but it's a scale and triangle. Okay, the in circle touches BC at D. Okay, this is D, point D. Then CA at E, D, E, F, basically, these tangential points. Okay, let R be the radius of this in circle. Okay, this is the in circle R, radius is R. Now there are three other incircles are drawn touching AB and AC, and another one at AC and BC. Okay, AB and BC, and then AC and BC. Okay, like this. These are the radius given. Okay. determine the radius of the a bigger inner circle, that is r. We have to find the value of r basically. Okay. Now, yeah, for this one you should know this formula actually. Okay. This is basically if I draw a line here. Okay. If I draw a line here, okay, AXY, let's say AXY is a triangle where this is inner circle and this big circle is the extra X circle, correct? So using this in circle and X circle, we have a formula for radius of X circle. Okay. So circle of radius R is X circle for the remaining three circles. If I draw line here, okay, line here, there X circle. So the radius formula is R equal to square root of RA into RB. Let's say each one is RA, RB and RC, then it will become square root of RA into RB plus square root of RB into RC plus square root of RC into RA. Only thing is note down, if this line here XY, whatever we are calling XY, if XY is parallel to BC, then this is not the equation. Okay, that time equation will become R equal to RA plus RB plus RC simply. Okay, that's a case of like equilateral triangle mostly, or yeah, equilateral triangle definitely that's the case. In that case, R is equal to sum of three radius of these circles. Okay, so note down, this is scalene triangle which is clearly given. That's why this is the formula. Now we have all three values, so just substitute, you will get 24. Okay. Only complicated thing is remembering this circle property. So again, you need to be good in geometry. You should know all these things before. Okay. If you know, it is very easy problem, right? Just a substitution. And make sure that you don't go wrong because the other problems I have seen, there are some other problems where it is given that this line is parallel to BC. XY, if I call it XY is parallel to BC, or this XY is parallel to AC, like this it is given. So in that case, the formula is different. Therefore, next. A light source at the point 0, 16 in the coordinate plane casts a light in all directions. Okay, at M. Okay, 0, 16. This is a disk. The circle is a disk of radius 2 at the with the center at 6, 10. This P is 6, 10. Okay, casts a shadow on x-axis. AC is the shadow. The length of the shadow can be written in the form of m square root of n, where m and n are positive integers. Okay, find m plus n. Okay, just remember you have to find m plus n, not m AC length. Okay, so this looks easy with the Pythagoras theorem and coordinate geometry. You can prove easily. AC is the shade of the disk, of course. MVP has a slope of -1. Why? You have 2 points here, MBP, okay, 2 points. Slope is y2 minus y1 by x2 minus x1. You substitute, you will get the slope as -1, which means, okay, this point, this is a, whatever is the, if you see the from slope, you can easily find out the distance of this one. Okay, this is 16, 0, because the equation you will get is x plus y equal to 16 you will get. If you see x plus y is 16 here, x plus y is 16 here, so you will get another x plus y is 16, that is 16, 0. Okay, so B is 16, 0, which means OB equal to OM. Okay, because this is also 16 distance, this is also 16 distance. Okay, that means this is a right angle isosceles triangle. Okay, so MBO is 45 degrees. Okay, this is 45 degrees. And BMA, if this is phi, if I assume this is as phi, then BMC also will be phi. Okay, BMC also will be phi, because M and N, MA and MC are tangents to this circle, right? From the same point, correct? So both angles will be same, phi. Okay. Now AMO is equal to 45 minus phi, because this whole angle is 45 degrees. So this is phi. So this is 45 minus phi. And OMC complete. This is 45 degrees. This is phi. So 45 plus phi. Okay. Now in triangle MAO, this is a right angle triangle. Okay. OA by OM is tan of this angle. Okay, this angle is 45 minus theta. So tan 45 minus theta equal to OA by OM, which is OA by 16. OM is given, so we know OM is 16, so it is OA by 16. In MOC, this bigger triangle, same thing. You apply again tan of 45 plus theta, you get OC by OM, that is OC by 16. Okay. So in triangle MPX, this is the triangle here. It is given this is 90 degrees because this is the tangent, right? Okay. This is angle phi. So tan phi equal to XP by MX. Okay. XP is nothing but radius of the circle which is given as 2. And MX is, you can easily calculate hypotenuse from the Pythagoras theorem. Sorry, adjacent from the Pythagoras theorem. This is adjacent, right? 90 degrees angle. So PM square, that is hypotenuse square minus XP square, opposite square. Which is equal to 1 by square root of 17 is what you will get. Okay, these are the angles. Now remember this tan equation. You need to apply this. Okay, these are the two given things, right? Three given things. Tan 45 minus theta, this one. Tan 45 plus theta is plus phi is this one. Tan phi is this value, right? So you apply this equation. Tan 45 minus phi equal to 1 minus tan phi by 1 plus tan phi, which is equal to square root of 17 minus 1 by square root of 17 plus 1 after simplifying, okay, which is equal to OA by 16, correct? So OA equal to 16 times square root of 17 minus 1 by square root of 17 plus 1. Similarly, from here you get OC equal to 16 times square root of 17 plus 1 by square root of 17 minus 1. Now AC is, you know, AC is OC minus OA, correct? So you subtract the and simplify, you get AC as 4 square root of 17. Okay, it is in the form of m square root of n. So m plus n is what we are looking for. M plus n equal to 21. This is the answer. Okay, so this is moderate. You need to apply multiple things: geometry, coordinate geometry, as well as calculus. Okay, next. For a positive integer n, okay, this is square brackets n denotes perfect square integer closest to n. For example, square brackets of this brackets 74 is equal to 81 because this is the closest square, perfect square integer. Okay, brackets of 18 is equal to 16 because this is the closest. Okay, if that is what definition, then n is the smallest positive integer such that find n basically. Okay, brackets of 91, brackets of into brackets of 120 into brackets of 143 into brackets of 180 into brackets of n equal to 91 into 120 into 143 into 180 into n. Find the sum of the square of digits of n. Okay, let's see. Okay, this is what is given. So obviously I'll rewrite the closest to square is 100 into 121 into 144 into 169. Only this one I am still having in the brackets. Okay, now you simplify this. Okay, either you divide or you just factorize and subtract. These are repeated actually from both sides. So you remove them, what you will get is 11 into 12 brackets n equal to 7 into 18 n. Okay, so you simplify further, you get is 22 brackets n equal to 21 brackets n. Okay, right? So if n is equal to, from this we can easily see n we have to substitute, brackets n we have to substitute 22 into 21 and you will get square root of closest to square root is 21 into 21. Okay, so if you put this value, okay, if you put this value, then LHS and RHS are equal. Okay, so now n is equal to 22 into 22. This is actually this is not the answer. So even if you see, even I have done mistake. Is asking for the square of digits of n. So n is nothing but 21 into 21. N is, okay, n is 22 into 21. So now you have to 462. So you have to find the square of digits of n, then that is the answer. Okay. Sum of square of digits of n, that you need to find out. Okay. It's easy, but don't do mistake like me. Next. In the figure below, four of the six discs are to be colored with black and two are to be colored with white. Okay, four are with black, two are with white. So these are the patterns, and he is telling that mirror image and rotation are considered as same image. If by mirror image you get the same image as any of the given, you should discard it. Also rotation. Okay. So for a disk of six disks, these are the possible options. If you put four black and two white. Okay. Now the question is, if there are four such colorings for the given two colors, right? As shown in the figure one, above figure. In how many ways can we color six discs such that two colored black, two colored white, and two colored blue? So you have to use black, white, and blue color, two each. How many such combinations you can make? This is the question. So this is less of mathematics, more of analytical actually. Just have patience to solve this one. Okay. First check how many ways two colors can be applied. Okay. Four ways. These are the four ways. If I put two blue, okay, blue here, blue here, blue here. Any other combination will be either mirror image or rotation. You will get the same. Okay, so these are the four. Correct. Now what we have to do is you take each of the pattern and see how many ways you can apply other colors. That is the easy way. Okay. So with this one I can apply six ways actually. These are the six patterns. Similarly, you try yourself with the other three patterns. Okay, you will get four each actually. Rest all will be either mirror image or with the rotation you get the same combination. So four each. Total combinations we have, total possible ways are 6 plus 4 plus 4 plus 4, which is 18. Okay, this is the answer. I think this is moderate to easy basically. Yeah. It's an analytical question more than mathematics. Okay. Thank you. So, if you see the tougher questions are more of thinking than, I mean, it's not lengthy questions. They are not lengthy questions, right? You have to think more and answer, and you have to apply your analytical brain. And each one is a combination of multiple things actually. Okay, multiple mathematical chapters, right? So that is what you need to apply. Okay. I will come up with the last video of this IOQM 2021. My next video will be the last one for this paper. Okay. Then we can see how easy, how difficult it is. Okay. Thank you.